All right, guys, I'm sorry I'm not there, but I want to try and move class along a little bit. So I'm going to try and teach you about precipitation reactions. You probably know that precipitation, you think of rain or snow, sleet, hail. Precipitation means that something is falling out of a solution. Air is a solution, so when the water can't be held by the air anymore, it falls out, it precipitates. Okay? In reactions with solutions, sometimes something is made that the water just can't hold and it precipitates out. Okay? So we're going to take a look at that process first. You have to understand that a precipitation reaction is a double replacement reaction. So we're starting with two ionic compounds and we're going to make two ionic compounds. Now the thing about that is, let me grab a little marker here and do some writing. Okay. What we have to understand is that ionic compounds are always made with a cation, a positive ion, and a negative ion. And same thing for the other one. Now, technically, the charges aren't just +1, -1 for everything, but it's positive, negative. So lithium is attracted to sulfate and calcium is attracted to chloride. But if the water breaks them up, not only could the lithium bump into sulfate, but the lithium could bump into chloride. So one product that we expect would be lithium chloride. And likewise, calcium is attracted to chloride, but calcium could also now be attracted to sulfate. So the other product that we would expect would be calcium chloride. All right, so let's write that out first in words again. So we're saying lithium sulfate plus calcium chloride is going to make lithium chloride plus calcium sulfate. All right, now from words, we got to break out our nomenclature and go to town here and say, all right, lithium sulfate, Li2SO4. And we're told it's a solution, so that means we could assume it's like aqueous. Then we have calcium chloride, okay, that's CaCl2. We're told that's a solution. We know that's aqueous. All right, now we figured out the products are lithium chloride, that's LiCl. Now notice that even though there's two Cl's here, I don't worry about there being two Cl's here because lithium is +1, chloride is -1. It's just lithium chloride, LiCl. And then calcium, we said that the other product is calcium sulfate. Well, calcium is +2, sulfate is -2. So we get just CaSO4. Now I jumped the gun there a minute ago because I put in this aqueous and I didn't need to do it yet, but so let's go back to that. We weren't told that this is a solution, so I have to go to the solubility rules now, and I look at my solubility rules, scroll a little too far there, and I see that lithium compounds are always soluble, so that's why lithium chloride was aqueous. But if I look at sulfates, I see that calcium is listed as an exception, so that means that I know that calcium sulfate is not going to dissolve in water, so that's going to stay as a solid. Ionic compounds are pretty much always solids unless I tell you otherwise. Okay? So this reaction here, bold to make it stand out a little bit, is not balanced yet. So we're going to put a 2 in there. Now it's balanced. Okay? This reaction is referred to as the complete molecular equation. Fancy term. I know we didn't use that term yet. Okay, it's because it's complete that everything is written as compounds. There's no ions or anything else. But our goal today is to get to this thing here that says net ionic equation. So you remember the other day we talked about dissociation a little bit. So now we need to talk about dissociation of these. Okay, so lithium sulfate is aqueous, which means that it would dissolve. So that means, let me get out of this mode here. Okay. So we're going to have lithium ions that are aqueous, and specifically I'm going to have 2 of them. Actually, let me change colors here just to make this one stand out a little bit. That's not what I meant to do. Okay. So we have lithium ions. We have a sulfate ion. And that is good, shifting between the superscripts and subscripts. Bear with me. All right, then calcium chloride, it says aqueous, so that means we're going to have calcium ions and chloride ions. And again, because we're 2 chloride ions, I put a 2 there. All right, so now we come to the arrow. The other side of our equation, we have lithium chloride, which is aqueous. But now there's 2 lithium chloride, so I'm going to say that's going to give me 2 lithium ions. And 2 chloride ions. Okay. And then finally I have the calcium sulfate, but that is not dissolving, so it can't dissociate. So it just stays as CaSO4 solid. Now this reaction that we just wrote is called the complete ionic equation. So we read with that a little bit, make sure I not set up. Okay. So in the complete ionic, we showed dissociation for everything that could. So now we have ions in it as opposed to molecules in it. Okay. But we have to think a little bit about algebra here for a second. Notice that we're starting with 2 lithiums and ending with 2 lithiums. Well, if I'm starting with these ions and I'm ending with these ions, what are they doing? They're not doing anything, okay? So I'm going to come down here and write the word spectator ions. Ions that sit and watch, but don't actually do anything. Okay, so the lithium, the fact that I have 2 lithiums here and here, they're spectator ions. Yeah, that was a bad cross-out job. Okay, and I see the same thing with chlorides. I see that I have 2 chloride ions here and 2 chloride ions here. So I have 2 different spectator ions, lithium and chloride. So if we get rid of the spectator ions, okay, then that brings us to where we want to be, which is what we call the net ionic equation. So let me actually just do a little copy and paste to save myself, and then I'll change the color. So we're saying that I didn't cross out calcium and sulfate, and I didn't cross out the calcium sulfite. Okay, so that's the only things that are not canceled out. So that now represents our net ionic equation. So the first one is essential. I'm always going to say that you should write out the complete molecular. The goal is to get to the net ionic. If you can figure out how to get by without doing this complete ionic step, that's fine. I'm never going to assign points to it. It's an intermediate step that some people like to use, but others don't. Okay, so it's really no big deal if you choose not to. All right, so now let's repeat the process here and go through this. So I'll break it down in words, and you don't have to do this part either, but I'm just trying to make sure we understand. So, wow, good typing. So we're taking magnesium nitrate plus ammonium carbonate. And from that, I am expecting to get, well, let's swap ions around. So magnesium has got to go now with carbonate. And ammonium now has to go with nitrate. Not nitrate ammonium, ammonium nitrate. Remember, we always put the positive before the negative. Okay, so there it is in words. Now we're going to make formulas out of it. So magnesium is a +2 ion, nitrate is NO3, and so nitrate is also a -1. So you need 2 of those. Okay. And we're told that's a solution, so we can go right to that. Ammonium is a +1 ion. It's NH4. And I'll need 2 of them because carbonate, CO3, is 2 negative ions. And that is also aqueous. We're told it was a solution. All right, so now we're going to make magnesium carbonate. Well, magnesium we said was +2. Carbonate is -2, so that's just MgCO3. I don't want to jump the gun. And then I'm going to take ammonium with nitrate. Well, we said ammonium was +1, and nitrate was -1. So we get that. So now let's jump down to the bottom again. Look at those solubility rules. Okay, we have our 2 compounds, our magnesium carbonate and ammonium nitrate. I see right here ammonium and nitrate are one of the ones that always make soluble salt, so that one's good to go. I don't see anything about magnesium or carbonate. That means we assume it does not dissolve. So the magnesium carbonate is the precipitate. It is the solid. Oh, I forgot to use that word in the last one. Okay, so the solid material that's being made, that is our precipitate. So in the previous question, okay, the calcium sulfate was the precipitate, and in this problem now it's the magnesium carbonate that is the precipitate. In theory, it is possible to have 2 precipitates. It's very, very rare. And it's possible to have no precipitate, okay, if everything is aqueous, but we'll get to that later. Okay? All right, so now just like before, I'm going to switch back to my red here, and let's go to our... Oops, again. Okay, so let's now talk about dissociation. So this is aqueous. So we're going to get magnesium ions out of it. And 2 nitrate ions. This one's aqueous, so that means we're going to get 2 ammonium ions. And a carbonate ion. All right, the magnesium carbonate is a solid, so that I can't change. That's just got to stay the way it is. But the ammonium nitrate, oh, hey, who didn't interrupt me? JC, this is on you, bud. You should have said, Mrs. Holman, you didn't balance that one before. All right, there it is. I should have put a 2 in there. All right, so we should have then 2 ammonium ions here. And 2 nitrate ions. Okay, so there is our complete ionic equation again. Let's look for spectator ions. What am I going to eliminate? Okay, I'm going to come down here, do this. All right, and let's change the color. Let's make it that blue that I like. Yes, I like the color code. Back off. All right, tell me. Anyway, all right, so I see that I have 2 nitrates on both sides, so I'm going to get rid of the nitrates. And I have 2 ammoniums on both sides. And there we go. That is our net ionic equation. That is the goal right there. Okay. All right. So I want you now to try numbers 3, 4, and 5. Pause the video, and I'm going to start putting them up. Okay. So go ahead, hit pause, give them a try, see what you can get. Help each other, and ask Christian for help if you need it. I'm sorry, Erin. Wow. Sorry. Wow. Ugh. Anyway. All right. Moving on. All right. So let's go. 10 acetate. So we're going to go C2H3O2 4 aqueous plus 4 KOH. I guess I'll do the balancing separately. I won't try and act all showy and knowing everything. Alright, so the products, we're going to take the tin 4, put that with the hydroxide. So I'm going to get tin 4 hydroxide, so SNOH 4. Don't know what that is yet. And we're going to get potassium with the acetate, so K C2H3O2. Oop, jumped the gun. All right. All right, so now let's recheck our solubility rules. Rule 1 tells us potassium compounds are always soluble. That is aqueous. I don't have any rules for tin or hydroxide, so rule 5 says this is solid. That's our precipitate. But this time I am paying attention, and I noticed that there's 4 hydroxides here, but only 1 hydroxide here. I'm going to put a 4 in there. And there's 4 acetates here, and there's only 1 acetate here. I'm going to put a 4 there, and that gives me 4 potassiums, 4 potassiums. There is my complete molecular equation. All right, now I'm going to switch to red. And then we're going to talk about the complete ionic. So I'm going to go SN, 4 plus, aqueous, plus 4 acetate ions, 4 C2, H3, O2, minus aqueous. All right, I'm going to take the 4 KOHs, so that's going to give me 4 Ks. And 4 OHs. Alright, then I have my tin 4 hydroxide, SN, OH, 4 solid. I don't dissociate that, but the 4 potassium acetates I do. So I'm going to have 4K, oh, wrong button, 4K plus, and 4 acetates. Oh, I love doing acetates. C2, H3, O2, with the charge of -1. H2O. I didn't realize I hit pause on the video. That's where the confusion was. Alright, we're going to just adjust the window a little bit so I don't keep doing that. And I'll fix this. Okay. There we go. Alright, so now let's go to net ionics. So I'm going to copy this down. I'm going to change the color to my blue. And I'm going to look for my spectator ions. So I started over here. I see 4 acetates here and 4 acetates here. Let's get rid of that. I see 4 potassiums on the left and 4 potassiums on the right. I'm going to get rid of them. And bam, there is the net ionic equation. Woo! All right. All right. Erin again, I'm so sorry. Oh, I can't believe I did that. Anyway, let's move on to number 4. So, we have ammonium sulfide, NH4, 2S, aqueous, plus sodium, and A3, PO4, aqueous. Yeah, nomenclature is heavy in this one, right? All right. So ammonium is going to go with phosphate. So we're going to get NH4, 3, PO4. Don't know what that is yet. and we're going to get sodium with sulfide. So that's Na, natural bit, I just hit 2PO4. We don't know what that is yet. Oh, not Na2. Caught myself. Na3. All right. So now I look back at my solubility rules, and rule 1 says that ammonium compounds and ammonium compounds are always soluble, so they're both aqueous. So that tells me the answer already, but let's go through the process. First of all, let's balance. 3 ammoniums on this side, 2 ammoniums on this side, so we're going to make this a 2. We're going to make this a 3. Same thing with the sodium, 3 on this side, 2 on that side, so I'm going to make this a 2. Gonna make this. I did that backwards. That's the 2. What did I do? Oh, I wrote phosphates twice. I'm not restarting the video, guys. Sorry. Let me fix the mistake. It's Na2 sulfide, so it should be S. Okay, and that's why there's supposed to be 3 of them over here. Na2S. Just been that kind of day. That's why I'm making a video now. Alright, let's go to the complete ionic. Right up there. Alright. So I have 2 times... no, I don't. I have... Oh, I really just butchered this whole thing up, didn't I? You guys are having a ball laughing at this part. Ha ha ha, that idiot. Anyway, let's try again. Hi, I'm Mr. Solomon. Welcome to Honors Chemistry. So, let's go in here and start dissociating. So I have 3 times 2, or 6, ammonium ions. I have 3 sulfide ions. I have 6 sodium ions. I have 2 phosphate ions. Now we go to the other side. I have 6 ammonium ions. I have 2 phosphates. I have 6 sodium ions. I'm going to run out of room here, and I have 3 sulfide ions. Right, so we can get rid of some spaces, try and compress this down, make it fit a little bit better on my mind, because I'm just that kind of guy. Space for 2. Get space from there, get space from there. I'm going to have to just almost every extra space. No, that's not a space. That was anything. Still did do it. Oh, man. There we go. All right. Finally on the same side. All right. Well, everything is a spectator ion, right? Everything's the same on both sides. So after spending all that time, wasting all this time just to do that, we find out that nothing is sticking around. So there is no reaction. Whenever they're all aqueous, nothing happens. We just mix the ions and they just swim around and ignore everybody. Alright, let's see if I can do this last one without butchering it as much. So we have antimony 5-chloride, SbCl5, and we're told that's a solution. And we have lithium arsenate, that's Li3ASO4, and we're told that's a solution. We're going to make lithium antimony 5 arsenate, that's a big one, that's 3, ASO4, 5, and then I don't know what that is. And then we're going to make lithium chloride. Well, we did that one before, so it's still LiCl. And it goes like that. Now, I remember from before that lithium compounds, we said, are always aqueous, but there is no rule about antimony arsenate. That is our precipitate. So we do have a precipitate. Now we got to balance this beast. All right, so start with the biggest compound. All right, the fact that I have 5 arsenates here, but I only have 1 arsenate in this, I'm going to multiply this by 5. And I have 3 antimonies here. I only have 1 antimony here. I'm going to multiply this by 3. Now that gives me 15 chlorides, and I also have 15 lithium. So over here, I better put 15 in front of lithium chloride. So there is the complete molecular equation. Change to red. We're going to dissociate this bad boy. This time I'm leaving no spaces. All right, so 3 SB. We know that is a 5 plus because we were told it's antimony 5. And I have 15 chloride ions. All right, then the next one, lithium arsenate, that's going to dissociate, give me 15 lithium ions plus 5 arsenate ions. All right, but then the SB3, ASO4, 5 is our precipitate, that stays. And then we just get the 15 lithiums. And the 15 chlorides. Alright, let's finish this up. Alright, so change the color. Big amplifier coating. Alright, so I look over here, I see my 15 chlorides on both sides. Let's get rid of those. Bam. I see 15 lithiums on both sides. Get rid of those. Bam. And there we go. There is our net ionic equation. I hope you're able to follow that. We'll take questions on Monday, assuming I'm in. Thanks for watching. Have a good one, guys.